Jessica Massey, and I'm doing a presentation on genetic editing. And what genetic editing entitles is stem cell research, CRISPR-Cas9, and genetically modified organisms, also known as GMOs. And in the public, it has been backlashed and has a bad reputation from the media, news sites in recent years, but I'm here to tell you that it's not true. It's not harmful, and it's actually beneficial to the public. And this is, all the backlash and bad reputation is from lack of enlightenment and misinformation in the public. But genetic research can help with hunger, and it can cure diseases, and it can help the severely injured. And I've been to a conference, his name is Sam Ryan, and he told us all about genetic editing and the genetic research that's being done and everything that could possibly happen in the future and how it can help society. I also have celiac disease, which is an autoimmune disease and is a mutation in my DNA. With CRISPR-Cas9, it can be improved and it can cut out the mutated part of my DNA, and I can be cured of celiac disease. So I've done my own research on CRISPR-Cas9, and that's why I am very informed on this subject. So we're going to discuss stem cell research first. What stem cells are is a cell that's not programmed to do anything, and it comes from an embryo, and it can be turned into 220 somatic cells. And somatic cells are body cells, so it's a nerve, a liver, a brain cell, any of that. And there's three types of stem cells. It's the embryonic cell, adult cells, and cancer cells. And embryonic cells only live for up to 10 days. And so before that 10 days, it can be made into any one of these body cells before it dies. But this is how we extract embryonic stem cells. Is you take it from in vitro fertilization, 3 days you get totipotent cells, and then after all of that, you have 10 days, you have cultured pluripotent stem cells, which is what we use for stem cell research. So on our stem cell research, it can be made into multiple different cells. And it's used in nature, but we have modified it so that we can use it to our own advancements. And this is a scaffold of an ear, and these are scaffolds of a heart, liver, lung, and kidney. And the application of stem cells is you take out this nucleus of a cell and you insert your stem cells. And the stem cells can regrow into any of these. It can also grow into skin and whole limbs. And it's also called part of the cell replacement theory, where you can replace your bad cells. So if you're not making insulin because you're diabetic, you can make stem cells into your insulin cells and temporarily fix your diabetes. Also, cloning, it has been used in the past for cloning, but there's been recent studies about cloning a horse, and so that is where stem cells come in play. But there has been a halt on research due to ethical dilemmas and a controversy within the International Science Council of whether it's right or wrong, good or bad. And so that's why funding and research has pretty much halted at the moment. But in recent years, a scientist in Japan has come up with a way to grow stem cells instead of extracting them from an embryo. And so that is how we can come up with stem cell research, because we're not harming any embryos. And the stem cells came from Dolly, the cloned sheep, in last year's. And the product is you can regrow whole organs, and you can regrow limbs, whole skins. And so the military has seen an interest, and when soldiers come home and they don't have limbs or they have wounds, severe wounds, you can help them with their own bodies with stem cell research. And their bodies won't reject the limbs or organs because it's made from their own stem cells. So there will be no rejection of organs or any of that. And it can also be used in emergency medicine, also for the same reason. And it's also part of the Slaughterless Meat campaign, which is you regrow meat from an animal that you took the stem cells out of. And so it can help in many different applications. And next we're going to talk about CRISPR-Cas9. And what CRISPR-Cas9 is, it's clustered, regularly interspaced, short palindromic repeats. And what it essentially means in nature is a CRISPR is found in your body, and when you get a virus, it will cut out the part of the virus that makes you sick. And it'll essentially kill the virus off. So it is found in nature. But what scientists have done is they've taken the CRISPR and they've modified it into CRISPR-Cas9 is the most recent. And what it does is if you have a part of your DNA that you want to change or you want to cut out or edit, that is what CRISPR-Cas9 does. So for instance, my celiac disease is a point mutation. So there's one piece of my DNA that's altered. So what they'll do is there's a protein in CRISPR-Cas9 that will come in and find the specific point and just chop it out. And they'll replace it with a new DNA piece. And so that is called the cut and paste. And so the application for it has been celiac disease, blindness, AIDS, diabetics. And you can help cure and prevent diseases from happening in later generations, but also it can help in right now if you want to be cured of diseases, even diseases in the future like cancer. But it can also be abused in our society because of designer babies and muscle enhancements. Because you can determine the sex of your baby, the hair color, the eye color, the intelligence, the muscle, how fast they can run. You can all change that with CRISPR. So that's how it can be abused in today's society. And this is a dog that a lab has tested on in a canine test about enhancing the muscle on a dog. And so this was done with CRISPR-Cas9, and this is the dog beforehand, and that is the dog after CRISPR-Cas9 enhancements. It's not normal. And so that is how it can be abused in today's society. And there's also the ethical question about, will it be abused? Is it right? Are we changing things? Are we playing God? Things like that. That is why research has almost completely stopped except for cancer research. That is the only research that has been allotted to continue. And there's been no testing on humans, and there's no testing on fertile eggs. There's only been testing ever on infertile eggs. But genetically modified organisms are what we're going to talk about next, or GMOs. And GMOs are genetically modified organisms or any alteration within a plant. And it can produce food or not produce food because it's still food to something else. And so these foods have been modified in the past in our local shelves, and it's not been a big deal. GMOs can increase nutritional value. They can increase the color, how many vitamins you get from eating an orange. They can increase the vitamin amount. And so they've been used on our shelves, and they've been used in our society before. And one example it has been used is the golden rice. And what golden rice is it's a modified rice that increases your nutritional value that you typically get from rice. And it's been sent to third world countries, but because of differing political views, it has not been actually delivered to the people of those third world countries. But in theory, if they were to deliver it, it would help with malnutrition and discoloration of the skin and things like that, and it would just overall help the third world countries. And so instead of delivering regular white rice, you'll deliver the golden rice, which has better nutritional value. But it's also had backlash in recent media for being harmful, not being natural. It's harmful to the body, which is not true. That's all just things that have been popping up in media recently. And so that has caused a lack of funding within GMO research because of everything is trying to go organic. It's not helpful to have genetically modified food, even though it can help people who have lack of nutritional value in their foods, and it could just help our overall society and nutritional value. And another reason that it can help is through our Slaughterless Meat campaign, which can regrow meat from different animals using their stem cells. And it can be helpful if there's a disease in the herd and you can't pass it on to people, so that herd is useless, you can't take any product from it. This is how you can regrow meat through using the animal's products without getting the diseases. And then you can also increase nutritional value and make the meat overall healthier for people. And so in this recent world, people can be helped through genetic editing, through curing diseases. It can help severely injured people. It can help our food, and it can make food be made faster and help our overall food problem. And so when you hear about GMOs, stem cells, cloning, any of that, and you hear backlash, just know that it can help people, and it does help people. And it can help with soldiers who lost an arm going to war. It can help people with diseases, blindness, it can help them. And it can help people who, like me, who don't get nutritional value because of diets and food restrictions. It'll help them, and it'll help third world countries, and it'll help the world. So when you think of genetic editing, it's not all bad. Thank you.